Imagine this. You're floating above a world that's perpetually locked in ice. No air, no sunlight warming the surface. Temperatures so cold they could freeze your breath in an instant. But beneath that seemingly dead, cracked shell, something massive is moving. An ocean deeper and vaster than anything on Earth. And in that darkness, hidden from every telescope we've ever built, life might be stirring, or something far stranger. Welcome to Europa, Jupiter's moon that keeps astronomers awake at night. Not because it's beautiful, though it is hauntingly so, but because it's terrifying in the best possible way. Today, we're diving into why this tiny moon is one of the scariest places in the solar system, and why it might hold the biggest clue to whether we're alone in the universe. Stick around till the end, because the real takeaway could change how you see life itself. Let's start with the facts that make Europa stand out among Jupiter's 95-plus moons. Discovered by Galileo in 1610, it's the second largest of the Galilean moons, roughly the size of our own moon. But unlike our dry, cratered companion, Europa is smooth, almost unnaturally so. Its surface is a patchwork of reddish-brown lines crisscrossing white ice, looking like a cracked eggshell painted by an abstract artist. Those lines? They're called linea, and they're fractures where the ice has pulled apart and refrozen. Some are thousands of kilometers long. The reason? Jupiter's gravity. Europa orbits close to the giant planet, and as it moves, Jupiter tugs unevenly, stretching and compressing the moon like dough. This tidal flexing generates heat deep inside, enough to melt ice into a liquid ocean. Some estimates suggest this ocean is 100 kilometers deep, twice the depth of Earth's Mariana Trench, and holds 2 to 3 times more water than all our oceans put together. Think about that. A moon smaller than Earth has an underground sea that dwarfs our planets. That's not just cool, it's mind-bending. But here's where it gets eerie. The surface is minus 170 degrees Celsius. Sunlight barely reaches Jupiter's distance. So how does anything stay liquid? Tidal heating. The same force that causes ocean tides on Earth is violently kneading Europa's interior, creating friction and warmth. Some models even suggest active hydrothermal vents on the seafloor, spewing mineral-rich hot water into the dark ocean. Exactly the kind of environment where life on Earth began, around deep-sea vents. Now, let's talk about why people call it scary. It's not monsters in the Hollywood sense, though sci-fi has had fun with that. It's the isolation, the darkness, the pressure. Picture this. If you could somehow drill through 15 to 25 kilometers of solid ice, thicker than many mountain ranges, you'd enter an ocean under crushing pressure up to 100 times Earth's atmosphere at the bottom. No light penetrates. Eternal night. And if life exists, it's chemosynthetic, feeding on chemicals from vents, not photosynthesis. That means any organisms would be adapted to extremes we can barely imagine. No eyes? Why bother? Perhaps bioluminescence like deep-sea creatures here, or entirely alien metabolisms. What if something intelligent evolved in that isolation? Not likely given the energy limits, but the possibility lingers like a shadow. Now, the ice itself is dynamic and terrifying. Chaos terrain regions look like jumbled icebergs frozen in place, suggesting massive upheavals where warmer water from below punched through melted areas and refroze chaotically. Plumes of water vapor have been spotted erupting from the surface, like icy geysers, meaning the ocean occasionally leaks into space. If life is in that water, bits of it could be floating in Jupiter's magnetosphere right now. And the radiation? Jupiter's magnetic field traps charged particles, bathing Europa in a deadly radiation bath thousands of times higher than Earth's. The surface is sterilized constantly. Anything alive must be deep under the ice, shielded. It's this combo hidden ocean, potential life, total inaccessibility that makes Europa feel like a cosmic locked room mystery. Something might be down there, but we'll never casually visit. To make this less abstract, let's connect it to Earth stories that mirror Europa's weirdness. First, think about Antarctica's subglacial lakes like Lake Vostok, sealed under 4 kilometers of ice for millions of years. When Russian scientists finally drilled in 2012, they found microbes that had survived in total isolation, using chemical energy. These extremophiles hint at what Europa's ocean life might be like: simple, hardy, and utterly alien to surface conditions. Another example: deep-sea vents on Earth's ocean floor. At places like the Lost City hydrothermal field, microbes thrive without sunlight, using hydrogen and methane chemistry. Entire ecosystems, tube worms, crabs, snails, depend on these vents. Europa's seafloor could have similar oases in the dark, isolated for billions of years. And evolution there would take wildly different paths. No plants, no predators chasing prey across sunlit plains. Then there's the 2016 Hubble detection of plumes on Europa water vapor, shooting 200 kilometers high. In 2023 to 2025, JWST observations confirmed carbon dioxide on the surface, likely from ocean chemistry bubbling up. Recent studies, as of 2026, debate seafloor activity. Some models suggest it's geologically quiet now, meaning less energy for life. Others point to ongoing chaos. It's this uncertainty that keeps scientists up at night. Personally, as someone fascinated by astrobiology, Europa reminds me of reading Lovecraft's vast, indifferent cosmos, where ancient things wait in the deep. But unlike fiction, this is real science pushing boundaries. NASA's Europa Clipper launched in late 2024 and will arrive around 2030. It won't land or drill, it'll fly by dozens of times, sampling plumes, mapping ice, measuring magnetic fields to confirm the ocean. ESA's JUICE mission also targets Europa, among others. These are our best shots at peeking without cracking the shell. But challenges remain. Radiation fries electronics fast, thick ice hides the ocean, plumes are intermittent. We might detect biosignatures in ejected material amino acids, complex organics, but proving life will be tough. So, why is Europa the scariest moon? Because it forces us to confront the unknown right in our backyard. A world that looks dead, but pulses with hidden potential. It challenges our assumptions about where life can thrive, not just in cozy Goldilocks zones, but in dark, frozen hells powered by gravity alone. The big takeaway: the universe is weirder and more resilient than we think. If life exists on Europa, even simple microbes, it means biology isn't rare or fragile. It means life could be common in the cosmos, hiding in places we'd never expect. Europa isn't just a moon, it's a question. Are we truly alone? The answer might be dripping from icy plumes right now. If this blew your mind, like, subscribe, and drop a comment. Would you want to explore Europa's ocean if we could? Thanks for watching. Stay curious, stay wondering.